All right, so the next topic is law of sines and cosines. Do you guys remember this from geometry? Hopefully. All right, so law of sines, it says in any triangle ABC, the following is true. So you can have sine of capital A all over little a equals sine of capital B over little b, which is equal to sine of capital C all over little c. So remember, the little letters are your side lengths, and your capital letters are the angle measures. Now this could be the other way. You could have the reciprocals of all of them. So little a over sine of A equals little b over sine of B equals little c over sine of C. You could have that as well. Okay, we use law of sines whenever we have angle, angle, side, or side, side, angle. Okay, it will be really easy to tell if you can use law of sines or if you can't. So if you have two angles in one side, so just look at this part. If you have two angles and one side, does it make sense that you would be able to find that missing side? Okay, if you had two sides, so if I had two sides in one angle, does it make sense that you'd be able to find the missing angle? Yes. Okay, so it'll be really obvious. You don't need to remember all the angle, angle, side, 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 angle, all that. Okay. I did hear someone say, I thought SSA didn't work. And you're right, it doesn't. This is going to be a weird one. Yeah. All right, so if angle A equals 115 degrees and angle B equals 27 degrees and little a equals 45, find the other angle measures and side lengths. So I'm going to set it up. I'm going to do sine of capital A over sine, or all over little a, equals sine of capital B all over little b. So sine of capital A is sine of 115 degrees. Little a is 45. Sine of capital B is sine of 27 degrees all over little b. Okay, so I'm going to cross multiply. So I'm going to have b times sine of 115 equals 45 times sine of 27 degrees. So divide by sine of 115, so I'm going to get b is equal to whatever 45 times sine of 27 degrees is.
Do you have to do anything special since they're degrees?
Just make sure your calculator's in degree mode. So hit mode, and then arrow over to degree. It's the third line. All right, so I have 45 sine of 27, and then I'm going to divide by sine of 115. So check on your calculator, make sure you get the same thing. I got b is 22.542. Okay, we'll do 3 decimal places if it doesn't say. Did you guys get that? All right, that is one of the side lengths. That's not all of them, though. So I have little a, I have little b. I need to find c. So little c, and I also need angle c as well, right? So I need little c and angle c. Do I need anything else? I think that's it. Okay, are either of those easy to find?
Yeah.
Which one? So capital C is going to be whatever 180 is, minus the 115, minus the 27. Okay, so when I do that, I got 38 degrees. So I have little b, capital C, I need little c. So now the last thing you need to do is set up another law of sines equation. So we're going to do sine of capital C all over little c. I always write sine there. Little c equals, yeah, why would we not want to use b? Yeah, what if we messed up this value of b? So let's go ahead and use a just in case. So I'm going to do sine of capital A all over little a. And that's okay if you use b, but usually, you want to try to avoid using something you found before. So I'm going to have sine of 38 degrees all over little c equals sine of 115 degrees all over little a. So cross multiply. So I'm going to get sine of 38 times 45 equals C times sine of 115. So do you guys see I'm going to divide by the 115, the sine of 115? Oh, and when I taught geometry, it always drove me crazy. People always canceled the signs. You can't cancel signs. It's always sine of something, sine of something. That angle's called your argument. So the sine and the argument always go together. You can't like separate them without using inverse sine. So you can't just cancel those. Do people do that in your class, Mr. Syrick?
Once.
Drives me crazy. All right, so I got C equals 30.569. Did you guys get that? We. All right, we're good. So these can be a little long. You have to find a lot of things, but they're not too bad. Okay, next up. Okay, John wants to measure the height of a tree. He walks exactly 100 feet from the base of the tree, and he looks up. The angle from the ground to the top of the tree is 33 degrees. But this particular tree grows at an angle of 83 degrees with respect to the ground, rather than vertically, so 90 degrees. How tall is the tree? Okay. Mine's so sloppy. That's okay. Okay. So this is 83 degrees here. So let's say this is my tree. My tree looks terrible. Yeah. It's growing sideways. Hey, you never know. I've seen trees like that. All right. There's a tree in my neighborhood like that right over someone's house. Kind of scares me. All right, so this angle is 33 degrees, so the angle that you're looking up to the top of the tree. And you're 100 feet away. Okay, we need to find how tall is the tree. So let's find h, the height. Okay, so looking at these different things, in order to find h, I need to use 33 somehow, right? So I'm going to have sine of 33 degrees divided by h equals, and I know I need to use 100 because that's the other value I'm given, but I don't have the angle across from it. So what do I do? Yep, so this angle right here is going to be 33 plus 83. You're going to subtract it from 180. So in other words, 180 minus 33 and then minus 83. Because it's always the angle that you have over the side length across from it. So h was across from the 33. Okay, what do you guys get for this angle measure?
64.
That's right, so that's 64 degrees. So that means I have sine of 64 degrees all over the side across from it, 100. Okay, solve it out. So I'm going to cross multiply and I get 100 times sine of 33 equals sine of 64 degrees times h. So I can see I'm going to divide by that sine of 64. So I'm going to do 100 times sine of 33 and then divide by sine of 64. Did you guys get an answer? I got 60 point. 6.597. Okay, so maybe you had a 10. Look to see if you had 10 instead of 100 here, because you're off by one decimal place, right? So 61 feet is the approximate height. In these real life problems, you can round. You don't have to say 60.597 feet tall. Like, that's kind of weird. Okay, so here's where it gets tricky. So it says no. When we have angle, angle, side, there's always exactly one triangle that satisfies the given information. However, if you have side, side, angle, or that's the same as angle, side, side, right? That was always the bad one in geometry. Do you guys remember?
Yes.
All right, so if you have angle, side, side, the bad one, there could be one answer, no answers, or two answers. Okay, this is called the ambiguous case. So looking at this triangle, it's kind of hard. Do you guys see this segment right here that's in blue? Do you see if I put a little hinge on it and I swung it back and forth? It can swing over here. And it makes the same, like you still have this angle, the side length, and that side length is still 5. It makes a nice oscillator triangle there. Yeah, it's like you're just swinging it over. Yeah, so that means that you could have, let me draw it in red. So this triangle with 45 degrees, 6, and 5. Or you could have this triangle with 45 degrees, 6, and then 5. So either one. Those triangles are not congruent. That's the angle side, side, right? That's the bad one. All right. So when you have angle side, side, you can't necessarily say they're congruent. So that's why. You don't get how they're the same because you have 45 degrees or a length of 6 and then a length of 5. So angle, side, and side is the same as angle, side, and side. See that 5 is the same length.
What if it was, okay, so you have the red one and it's 45, 6, and 5. What if that blue one was 45, 6, and 8 or something?
Yeah, then you could have 8 here and 8 here. Yeah.
The numbers need to be the same.
Yeah, I'm saying you could have them being the same number, and that disproves the angle side side. So angle side side is not true because you could just swing this side over and get a different triangle. All right, so you always want to look and see if you have angle side side going on. So you can always draw out a little triangle. So we'll call it A, B, and C. Right now we have little b is 8, little c is 5, and we have angle C is 54. So when you see this, do you guys see how if you go around in order, you have an angle, the side, and the side? So that's bad. So that means you're either going to have 0 answers, 1 answers, or 2 answers.
Wait, can you explain that again?
See how it's angle, side, side?
Oh, yeah.
Yeah, the angle first, then a side, then a side. Okay, so when you set it up, you try to use law of sines. You say sine of 54 degrees all over the length across from it, 5, equals sine of angle B all over the length across from it, 8. We solve it out. So you can cross multiply, or you can think of just multiplying this 8 over, right? Same thing, you're just getting sine of B by itself. So I'm going to have 8 times sine of 54 degrees all over 5 equals sine of B. So we don't know B. Do you guys see how I did that? Okay, when you do that, you get sine of B equals 1.2944. How do I solve for B? No.
-1.
Yeah, inverse sine, right? So I'm going to do B equals inverse sine of that answer that you have on your calculator. So what happens when you do that? Mine says error. Why is that an error?
No. This is she's doing.
Yeah, so why did I get an error? Why is it not possible, though?
Because it's an ASS triangle.
True, but sine is always between -1 and 1. Remember we talked about that before? Your sine is never going to be bigger than 1. Remember with 90-degree triangles, if you have theta, you have opposite over hypotenuse. Hypotenuse would always be the largest, so opposite over hypotenuse is always less than 1. We've talked about that. Okay, so sine values are always between -1 and 1. All right, so this is going to give you an error. So then this means there's no solution.
No solution?
All right, so in that case, the angle side side or side side angle gave us no solution. All right, let me pause this for a second.